Hello there, this is Ms. Nakayama, and today's lesson is 5.2, Sum and Difference Formulas. We are going to use the sum and difference formulas to find cosine, sine, and tangents of angles. So here are the formulas, and I really want you to pause and look at them. Just pause for 15, 20 seconds, okay? And notice, try to find how they're the same and how they're different, or what can help you remember these formulas. You do need to write them down in your notes. So after you have unpaused and you're back, I'm going to talk to you and show you, hopefully you saw that when you take the sine of an angle, that when it expands out, you have sine, cosine, and then you have cosine, sine. Actually, I wonder about that whole thing. Okay? When you take the cosine, then it's the same trig function both times, cosine and then sine. What changes here is when you have the sine, when you're taking the sine of the angle, the difference of two angles, okay, when this sine is minus, this is the same. But in the cosine, it changes. Now I'm pointing this out to you, so one of the things to remember, the sine, the trig functions are different, but the sines stay the same. And when you take the cosine, the trig functions are the same, but the sines are different. It's just a way to help you remember these. I'll talk a little bit more about it as we go through. Okay? Then you have the tangent. And the thing I like about the tangent is when you're taking the tangent of alpha minus beta, that's exactly what you see on the top. And then the sign changes on the bottom. So it's like you're distributing this tangent, which of course we know you can't, but that's what it looks like. It makes it easy to remember. And then, as I said, the sign changes on the bottom of it. Okay, so just some little nuances to try to help you remember these things. All right, so we got lots of examples to go through. First off, true or false? Cosine of 60 is equal to the cosine of 90 minus the cosine of 30. I think most people are going to want to say that's true. However, what is the cosine of 60? On a unit circle, it's 1/2. What's the cosine of 90? 0. And the cosine of 30 is the square root of 3 over 2. And clearly you know that 1/2 is not equal to 0 minus the square root of 3 over 2. Okay, look at the next one. Find the exact value of the cosine of 70, cosine of 40, plus the sine of 70, sine of 40. So what you need to recognize, this is the one where the trig functions are the same. And you look at your sheet, is that going to be with cosine or is that going to be the sine? Okay, and these two, when the trig functions are the same, that's the cosine of an angle. And I take those two angles of 70 and 40, and I just talked to you about, if the trig function was the same, then I know this sine is going to change and be the opposite. So that's going to make that the cosine of 70 minus 40, which is 30, and the cosine of 30 is square root of 3 over 2. Last time I checked. Okay? So simple. All right. Now we have use the formula for sines to find an exact value. So whenever you have to find the exact value of a problem, y'all, remember, the exact value means there's no decimals. You're probably going to have some kind of radicals in there. Okay? Find the exact value of it. That means you got to show me the work. And there's 2 steps. Same 2 steps every single time you do this. The first one is going to be to apply the formula. Okay? That is the sine of 3 pi over 4 minus pi over 6. So that's as if this is your alpha and this is your beta. So when I apply the formula, that means that I'm going to have the sine of the first one, cosine of the second. Trig functions are different. This is going to stay the same. And then cosine of the first one, sine of the second. So it's just applying the formula. It's just looking at the sheet using the formula, putting the alpha and the beta in for the angles. The next step is to evaluate. And on this step, y'all, it's all about parentheses. Every time you see a trig function, you have parentheses. Please don't put a trig function inside of the parentheses. That's not what this is about, okay? What is the sine of 3 pi over 4? You know, it's square root of 2 over 2. What's the cosine of pi over 6? All right, you have your unit circle if you need it. Cosine of pi over 6, we just did square root of 3 over 2. Cosine of 3 pi over 4, negative square root of 2 over 2, and the sine of pi over 6 is 1/2. And then you just simplify that. And when you look at that, and you have to simplify, y'all, notice that in this first grouping, 2 times 2, in the second grouping, 2 times 2. The denominator is the same, so all I have to do, 2 times 2, of course, is 4. Let's see where that is. Hello. Okay. It's 4. Square root of 2 times the square root of 3 is the square root of 6. Minus a negative is a positive square root of 2. And that's all you have. All right, look at this next one. A different variation of it. You're still using these formulas, y'all, but we're doing some identities. And again, it gives you the direction. So that's why I have the directions in these problems. Write the numerator on the left side using a sum or difference formula. Okay? I don't do anything to the denominator, so I just wrote it again. Okay? I do have to use a sum or difference formula with cosine alpha minus beta. And that is cosine of the first, cosine of the second. When the trig functions are the same, I'm going to change the sign, so it's going to be plus, and then sine of the first, sine of the second. The alpha and the beta always in the same order. All right, rewrite the fraction above as a sum or difference of two expressions. So this is just breaking it up and writing each numerator over the denominator. That's the first one plus the second one. And then it says divide out a common factor of the first term and use a quotient identity for the second term. Okay? Even if you don't know, y'all, it's the last step of the problem. And we've talked about identities before. And the last step of the problem is always going to look like the other side. But when you simplify this, excuse me, okay, this is the same. This is the same. Anything divided by itself is 1. Okay, carry down my plus. And then sine over cosine is tangent. So one of them is alpha and one is beta. So I have the same thing on both sides, and I verified an identity. Okay, another, find the exact value. Okay, this time, again, y'all, much easier with MyLab Math because they tell you exactly what two numbers to add together. Okay, a lot easier than if I just said find the exact value of the tangent of 5 pi over 12. But again, you have to find the exact value. And when you find that exact value, the first thing you're going to do is apply the formula. So in this case, that formula is I'm using these two things. Okay? Probably should have written that. But I'm doing the tangent of pi over 6 plus pi over 4. Well, using my formula, tangent of pi over 6 plus the tangent of pi over 4 over 1 minus tangent pi over 6 tangent pi over 4. The second step, always, always, always evaluate, which means I've got parentheses everywhere I had a trig function. What's the tangent of pi over 6? Square root of 3 over 3 in both places. What's the tangent of pi over 4? It's 1. So this part, that should be very simple, and if you can get that much, that will be at least half of the problem. You do have to simplify that. I'm going to show you how to do it. If you need some help, come see me. I find it easier. I've had more success with students if you simplify this in 2 steps. In the first one, I'm going to get rid of the complex fraction, the fact that I have a fraction in the numerator and or the denominator. So that means I'm going to multiply the top and bottom by 3 because that's my least common denominator. We've done this before. So when you multiply this by 3, this first one, that cancels out, leaving me with, I lost my guy, hold on. Okay, with just the square root of 3. And 1 times 3 is 3. Again, 1 times 3 is 3 minus, and that is going to cancel out with this 3 right here, which is like it did up top. But I usually don't write that because then it confuses people. Anyway, minus the square root of 3. So now I don't have a complex fraction, but I still have a radical on the bottom, so I have to multiply by the conjugate of the denominator. And that means that I'm going to use this denominator, 3 minus the square root of 3, and I'm going to change the sign of the second term. And that's what that looks like. So that gives me, I wrote the second one first. I always find it easiest to do the bottom first. So this right here, y'all, is like a minus b, a plus b. So when you square the first one, 3 times 3 is 9. And then it's always minus. And then the square root of 3 times square root of 3 is 3. So I have 9 minus 3 on the bottom. And on the top, I'm going to FOIL. So first term's 3 square roots of 3. Outside term gives me plus 3. Inside, plus 9. Last, plus 3 square roots of 3. And when I simplify that bottom, I get 6. 9 plus 3 is 12. Plus 6 square roots of 3. There is a common 6 in each of those. And when you simplify it, you get 2 plus the square root of 3. So if you had any trouble with this part of it, okay, that's where you need to practice, but you'll have practice in your homework assignment. Okay, another identity. Write the left side using a sum or difference formula. So I'm going to apply the tangent formula. Applying the tangent formula means I kind of distribute, but I'm not really distributing. So I'm going to have on top, I get tangent of x plus the tangent of pi over 1 minus tan x tan pi. Okay? And then it says, evaluate that previous expression where possible and simplify. So the reason they said where possible is because there's a pi in here and it's not a variable. And we know that the tangent of pi is equal to 0. So everywhere I have a tangent of pi, that's 0. And this is 0. And 0 means that whole thing is 0. So I have only a 1 on the bottom and only a tangent on the top. So I have tangent of x is equal to tangent of x. But you just have to show the work. That's all you have to do to verify that identity. Okay. Last 3 problems are tied together. It's one problem. It's like this is the last problem in your practice assignment, but it has 3 parts to it. I just have it as 3 different examples. Okay. But all of these are dealing with the sine of alpha is 4/5 for a quadrant 2 angle. This is important. And sine of beta is 1/2 for a quadrant 1 angle. Okay. And they're asking us again for the exact value. So I hope you know by now that means you're going to first and foremost apply the formula. The formula for cosine, my trig function's the same. So cosine alpha, cosine beta, I change the sign in between them. So that's going to be minus, and then sine alpha, sine beta. And then I'm going to evaluate. And evaluate means I'm going to have these parentheses wherever I have a trig function. I'm not going to put a trig function in the parentheses. I'm actually going to put a number, a coordinate. Okay? So how do I figure that out? Well, they gave me the sine of alpha. Sine of alpha was 4/5. And they gave me the sine of beta is 1/2. But I don't know the cosine of alpha or the cosine of beta. However, I can find it lots of ways. One of the ways we do is with those triangles. Here's alpha. All right, excuse me, if I have alpha and they told me that the sine of alpha is 4/5, okay, it's in the second quadrant. That's why I drew it in the second quadrant. Sine is opposite over hypotenuse, so that's 4/5. Use your Pythagorean theorem and find out that the missing side is 3. And I'm writing -3 because I'm in the second quadrant. Because I need to now know the cosine of alpha adjacent over hypotenuse is -3/5. So I'm going to go fill that in. The next one, beta, they told me that beta, they said the sine of beta was 1/2. Well, that should ring a bell to you that that's on the unit circle. So if the sine is 1/2, then I know that the cosine is the square root of 3/2. And they told me it was in quadrant 1. So there we have it. And again, I told y'all, look at this. They both have the same, when you multiply these two, that's 10. Multiply those two, it's 10. If you don't get the same number, y'all, you've done something wrong. So it's an easy way to check yourself when you're going through. So I have a 10 on the bottom, minus 3 square roots of 3, minus 4. That's all you got. Simple enough. If you do not have this work on your paper, you will not get full credit for the problem. Okay? That was cosine. Here is sine. Okay? What do we do first? We apply the formula. And sine says sine, the trig functions are different. So it's sine alpha cosine beta. But the sign in between stays the same. So it's plus. And then cosine alpha sine beta. And next I'm going to evaluate. Evaluate means I'm going to have parentheses wherever I have a trig function. Again, they told me the sine of alpha and the sine of beta. In the last part, they're tied together. I told you that. We know the cosine of alpha and we know the cosine of beta. Again, I got the same numbers on the bottom. So I have a 10. So I'm going to get 4 square roots of 3 minus 3. And that's all we got. Okay? Last example, finding the exact values of the tangent. The tangent can be a little more cumbersome because we've got to remember to rationalize and simplify. So I'm going to show you 2 different ways because sometimes one is easier than the other. Okay, so in my first method, I'm going to do what I've been doing the whole video, and that is when I have to find the exact value, I'm going to apply the formula. So in this case, tangent of alpha plus tangent of beta on top, 1 minus tangent alpha tangent beta on the bottom. I'm going to evaluate, which means I put parentheses everywhere I have a trig function, and then I'm going to plug in a number. Okay, what's the tangent of alpha? Okay, well, we know the sine of alpha, and we know the cosine of alpha. So if I know the sine and the cosine, then the tangent is sine over cosine, which makes that negative 4/3. So my tangent is negative 4/3. And then the tangent of beta, if the sine of beta is 1/2, we found out the cosine of beta was square root of 3/2, which makes the tangent square root of 3/3. So that is going to be filled in there. So remember I said to simplify, this is the hardest part of it, simplifying it. I'm going to get rid of my complex fraction first. And you look, this denominator is 3, this one is 3, but this one is 9. So I have to multiply the top and the bottom by 9 this time. Okay, excuse me. So multiplying it by 9, let's go with 3 goes into 9 3 times, so that's going to be negative 12. 3 goes into 3 9 times. 3 goes into 9 3 times, which is going to be plus 3 square roots of 3. 1 times 9 is 9, and then 3 times 3 is 9, plus 4 square roots of 3. So I've gotten rid of the complex fraction, and sometimes you'll be done, but I can't leave a radical on the bottom. So I have to multiply by the conjugate of my denominator, and that means it looks just like my denominator, but I'm going to change the sign of the second term. So that's going to be 9 minus the 4 square roots of 3 over 9 minus 4 square roots of 3. So I always find it easiest to do the bottom. That's a squared minus b squared. So 9 times 9 is 81. And 4 square roots of 3 times 4 square roots of 3 is 16 times 3, which is 48. And on the top, FOIL, I have negative 12 times 9 is negative 108. I think I didn't do the outside. I think I did the inside. Plus 27 square roots of 3 minus 40, plus, because 2 negatives are positive, 48 square roots of 3, and then minus 12 times 3, which is 36. And to simplify that, I'm going to get 81 minus 48, which is 33. Negative 108 minus 36 is negative 144. 27 and 48 is 75, plus 75 square roots of 3. You got to pay attention. There's a common 3 in all of those terms. There's 3 terms. There's a 3 in every one. If you take the 3 out, you're going to get 11 on the bottom. You're going to get negative 48 and 25 square roots of 3. So that's the answer. Now, look at method 2. Kind of like what I just did right up here, y'all. If you know the sine and the cosine, you can just put them on top of each other. And again, sometimes that's a lot easier to do. It's a, either way. So in this case, I knew the sine because we just did that in the last example. And then in example 6, we did the cosine. So the tangent, as I just said, is going to be sine over cosine, which means I'm going to put that sine over the cosine. Well, if I put sine over cosine, y'all, we've talked about this a lot. They have the same denominator. So when I simplify it, it looks like that. And I have to multiply by the conjugate of my denominator, which means I change the sign only of the second term. So that's negative 3 square roots of 3 plus 4. And to multiply that out on the bottom, 3 times 3 square roots of 3 times 3 square roots of 3 is 9 times 3, which is 27 minus 16. And on the top, if I FOIL, first terms gives me negative 12 times 3. Outside gives me 16 square roots of 3. Inside gives me 9 square roots of 3. And last gives me minus 12. And when you bring all that together and simplify it, you get minus 48 plus 25 square roots of 3 over 11, which is exactly the same thing. So, there you have it. Either way, you still got to simplify that radical. You have those formulas. You will have those formulas, but you got to know how to simplify. So if you're having any kind of trouble with that algebra, please let me know. Come see me, and we can work together to help you get it. Thank you so much for watching, and y'all have a great day.